Right. So, let's create the query we talked about in the previous video. We will store its first part in a variable called insert_query. In other words, we will assign the string insert into predicted outputs values to it, thus indicating we are getting ready to insert some information. How can this operation be programmed? By writing loops that will iterate over both the rows and columns, which means that when we are on the first row, we'd like to extract the value contained in its first column, then each subsequent column until the last. The same process must then be repeated for all rows. As the NumPy's shape method tells us, the iteration will go over 13 columns and 40 rows. Then, we must find a way to extract a single value from our table. But before that, you know very well how to obtain a list with the column names of a data frame, right? You need to run df newobservations.columns.values. Combine that with your knowledge on indexing in Python. Say you want to extract the name of the 7th column. In that case, it would suffice to add the number 6, written within brackets at the end of the line. We accurately obtain the name age. Therefore, we can now discuss two ways to pull all values from the age column. The first one would be to type the data frame name, df newobservations, and then indicate the column name, age. Note that age is a string. The second one requires us to use the entire structure we just developed. Placing it within the brackets and then executing the cell leads us to the same outcome. So far, so good. We know how to retrieve a column's values. How about retrieving a single value? If we'd like to extract, say, the first value of this column, we will need to add another index at the end. The number 0 must be written outside the second pair of brackets. Perfect! We obtained 30. And why did we introduce you to this more sophisticated syntax structure? Because you'll need it when writing the loop that will complete the insert query. So, here comes the loop. Wow! Instead of trying to interpret it element by element, it would be more helpful if we provided a more holistic explanation. The first block of code is our outer loop. It regards the beginning of each record we'd like to insert. More precisely, the first line says, we want our iteration to go through every row of df newobservations. That's why we've indicated we are interested in the first value obtained by the shape method. Also, we've pointed out we want to start the code of every record with an open parentheses. This means that when we finish writing the code on row I, we will start writing the code for the next row with an open parentheses again. Okay. And what should happen for every row I? We want to add the values from all columns corresponding to the given row, separating them with a comma. That's why we need a second inner loop here, which will repeat the next operation for every j. That is, for every column of our data frame. Then, we would like to turn the value obtained from each column into a string. And, finally, add it to our insert statement. The value we are talking about will be retrieved thanks to the structure we mentioned 2 minutes ago. We only have to substitute the indexes with the letters we used for iteration over columns and rows. They are j and I respectively. Consequently, since we have 13 values to specify for each row I, we must add a comma symbol at the end. At this moment, you may be thinking, but wait, the insert query syntax requires each row I to end with parentheses. Not with a comma. What should I do? Well, you can correct that with the third block we have here. It overwrites the content of the insert query by practically the same variable without the last two characters, the comma and the white space. Then, it replaces these two characters with a close parenthesis and a comma. This is a great example of using reverse indexing in Python, since we are indicating we'd like to remove the last couple of symbols by typing :-2 within brackets. All right, let's execute this cell. And now, let's check the content of our query. Essentially, this is the exact SQL insert statement we needed, displaying as a string variable in Python. With one little flaw, though. Compare the last symbol used in the two queries. Our Python string doesn't end with the proper statement terminator, which is semicolon. That's why we will correct the end of our insert query once more. This time, we'll do this outside the loop. Again, we will remove the last two characters from our insert query and then add a semicolon at the end. And as we check the content of the same variable, we see that this time we are ready. In other words, we have prepared a string we can deliver to MySQL. We'll do this in our next video. Thank you for watching.